Hello, my name is Julian Martin. I'm going to be talking to you briefly about science literacy and science media literacy. First, we're just going to briefly talk about what science literacy is. Science literacy is, according to the Program for International Student Assessment, the ability to acquire new knowledge and explain scientific phenomena. Now, this is talking to things like how does an organism grow? How does rain fall? What makes things stick to the ground? Gravity. And then once you acquire that knowledge, how to apply this knowledge in different ways, such as can we calculate how fast something is going to fall based on the rate of gravity? And then be able to gather and draw conclusions from evidence collected or presented to you. So look at something and go, oh, that fell that fast because gravity's faster, or the gravity's heavier on that planet where that whatever that was, something like that. Now the issue, the science in the media is a difficult job. Journalists really do have a hard job because they have to translate complicated things such as the methods, the terminology. I'll use the example of 1,2-bisphosphate triglycerate and try to translate things like that and put it into language that anyone can understand. So it is a bit difficult. And the goal of the journalist in the science realm should be to inform the public in an unbiased manner, inform them in a way that says, hey, this is what this research shows, and this is what the scientist thinks about it, not what we think about it. And the issue in the media with science comes when journalists stray from this path, when they stray from the this is what was found and go, oh, look, this is what was found, this is what we think. That is where the issue lies. And we'll just talk about three very large examples right now. In that, the first one is vaccines, that they cause autism. This is obviously a very false statement. I don't know what else to say about that except that it is false. And this came about because of one disgruntled pharmaceutical employee who published a falsified paper stating that, hey, there's correlation and causation that vaccines cause autism. And the world has just grabbed onto it since then. And then what made it worse was when famous people get on board, such as Jessica McCarthy, when she got on and said, hey, I'm going to make these ads that say vaccines cause autism. Don't vaccinate your kids, when it's not true. And the problem is the public has grabbed hold of it so strong that it's so hard to get them to understand that no, it's not true. And a second example, as you can see, is the flat earth theory. I don't know how this all came to be such a prevalent thing in our society, but apparently it is. I have a manager myself who believes that the earth is flat. And obviously, this is again not true. And this is something that has been disproven since the 500s, 500 BC. Some of the oldest mathematicians and astronomers known to man, Socrates himself, said the earth is round. So this isn't a groundbreaking thing that the earth is round. They knew it well before Christopher Columbus set sail across the ocean blue. And again, the issue becomes when people connect and make these false articles and then get famous people involved, the most recent being Shaquille O'Neal. Whether or not he's joking, the issue is that now people see that and they're like, hey, Shaq believes this, and they take more vested interest in it, and they don't think to check the facts. They look at what is presented to them and they don't question it. So that is what we need to teach our students, is critically evaluate what you're being presented in scientific journalism, whether it be articles, videos, blogs, tweets. You need to look at them and evaluate them from a critical perspective of, is this matching what the evidence shows? And so to do this, a third example, and this is one that touches near and dear to my heart, is evolution. Evolution is the process of, over successive generations, a species evolves into another species, or a subspecies breaks off and then evolves into another species. Now, if you go ask any kids today, not any kids, but a decent majority of kids nowadays, if you go and ask them, what do you think of when you think of evolution, I guarantee you're going to get, at least some are going to answer Pokemon. Because evolution's in Pokemon. I know, I grew up with these little guys. And the example is that this little guy, green guy right here, evolves into this guy when he gets strong enough, and then he evolves into this guy. Now that's all good and well for this game, but unfortunately it teaches this false evolution to kids. That, oh, an organism itself can evolve, when no, it's adapting and actually metamorphizing, or it's going through a metamorphic process, kind of like a butterfly. And so this is another thing you have to watch out for, because this isn't intentionally trying to harm the evolutionary name. It's actually just, I don't want to say, creative license almost. Like, hey, we know this isn't actually evolution, but we're going to use it because it sounds cool. And so it's not intentionally being malicious, but it's still causing confusion and misunderstanding of the actual terms. Now, to combat this, the most important thing you must do is to teach your students to analyze the articles that they are looking at. Whether the articles are written articles, are they blogs, videos, like I said earlier, you need to look at them and ask these questions. Who is this person? Is this person a grad student? Does he have his doctorate in physics and he's saying, yes, the earth is round? Or is this the guy who who works at the local office saying, hey, you know what, I don't think the earth is round, because when I look out I just see it's flat. That doesn't make sense to me. So you have them ask, who is the writer? Then ask, what organization is this published to? Is this published to the Flat Earth Society, or is this published to a university where one would hope and expect that the facts are going to be construed more accurately? And then, who is this written for? Is this written for students? Is this written for people of like-minded opinions just trying to further their biases or further their opinions? Is this written for members of the scientific community? And this maybe isn't something you should read because it's going to be very complicated, even if it is true. And then finally, or not finally, next, what is their primary source? Now, this is probably one of the most important things, is the primary source. And primary sources are your research articles, your journal articles. This comes from the sweat and tears of scientists who spend sometimes years or decades looking at this information, these numbers, these calculations, and trying to come up with an explanation for what they see. And to do this takes a long time, and then to get it published, it goes through a rigorous process. It's not just, okay, I think it says published. No, it gets critiqued, it gets rewritten, it gets critiqued again, it gets rewritten. These primary sources, they have to be good to be presented to the public. So teach them that if these primary sources are research articles, that these are the good articles, and not just, well, this person said it, so this person said it, and this is what I see, so I think that. Those sources aren't good. You want the research articles, you want the journal articles that have gone through the grinder. And then finally, what is the goal of writing or producing this piece? Is the goal of this to inform you? Is this goal to say, hey, look at these scientists over in Alabama just discovered a new way to grow kidneys? Sweet. And obviously it's not going to go into the process. Maybe it'll give you links to more information, but it's just informing you. Or is this attempting to persuade you to think, oh, look at this. This is actually a good method of clean energy. This is actually smarter. Or is it something else, like attempting to intimidate you or cause you to feel fear, such as the vaccines cause autism? Trying to make you worry that, oh my God, if I do give my kid this, will he get autism? So that is a legitimate way that some people write, or some not even just write, but they produce their media to strike these chords. So teaching your students to look at this, what are they trying to do? What are they trying to influence? And then Check the sources. Don't just see that, okay, yes, it's cited, that means it's true. No, go to the source. Check it, even if it's just a brief glance. Even that brief glance can give you a good opinion of, hey, this source matches what the article or what the author has written. Okay, great. Or produced. That means it's good or not. But if it doesn't match, makes you start to question. Maybe this person has an ulterior motive, or maybe it was just a mistake. But maybe I should take this article with a grain of salt. And for an activity for this, other than evaluating or having them evaluate articles and such, another activity would be to provide students with a relevant discovery to your subject and have them develop their own articles or videos or blogs or tweets that will be published to the community. They don't have to be, but just say, this is the goal. This is what you would publish to the community. So this needs to be presentable. And this makes them translate what they've read into a context that anyone can understand, and makes them see it from the other side, and make them understand the process of writing an article, and make them work towards making the article as unbiased as possible, and make it just as an informative an article or video or blog as possible. Now, for this part, I would be giving a handout with an article that I would be presenting to all of the members of the development course and hand it back and go, okay, here is a article and I want you guys to evaluate it, and here are the sources. Evaluate it. Tell me if this is a good article. And you can see that in the handouts section, the handout turn-in portion of our project. And then I would also suggest I would hand out this PDF that I found through Ithaca College of one of many methods to develop a media curriculum. And in it are 12, as it says, 12 basic ways of teaching media literacy in any subject, but especially in the sciences. And then I would suggest Google. There's so many different ideas that I came across going through the internet. But again, check those sources. Is this a company who is just going to make a quick buck by, hey, look at what we developed? Or is this somebody who has, or a group of individuals who has gone through and made sure that this process works? And then after the activity, I will go into the next part. And this is just a small part. I'm going to talk about biology essentialism. Genetics and biological essentialism is when a student reads a text that is written in a way that is racially framed. It is written so that it says something along the lines, and this is a made-up statistic, that says 20% of African Americans will commit a violent crime in their lifetime. And this is based on a gene found in them. This allows students to rationalize that, okay, there is a genetic difference between them and us, or us, the people who are reading who the articles are referring to, and others. And what this does, it allows students and individuals in general, adults as well, to rationalize more differences based on genetics. Saying, okay, well, we're different according to the article because of this. Well, why can't we also be different because of our success in socioeconomic class, because our genetics are different? And the problem is that racially framed genetic articles begin to allow for those thought processes to form, and it doesn't combat those biases. So to combat that, you need to evaluate the readings and attempt to select readings that are non-racially framed. Make sure that when you're going through, it's not targeting certain groups by pulling out statistics and things like that. Statistics that are racially framed and potentially make a group of students think less of themselves or less of another group. And the one important thing to note with this is that there are still times where giving racially framed statistics is important, such as, and if you look in the handout, I provided several that are true, that I forget the exact number, but it was, I believe, 1 in 100,000 European Caucasians will develop Huntington's disease. That's a relevant statistic, but it needs to be provided in a context you understand, like, this doesn't mean that there are a lot of differences between you and I. And so that you need, and so this is a difference, but that doesn't mean that we're crazy different. And then another one would be, I believe it was 1 in 13, potentially 23 African American births has sickle cell. That doesn't mean that we're completely different, and that explains all the differences in our complete society. So it's just important to frame it in a way that even if it has those racially framed statistics, that it doesn't allow for those type of thought processes and biases to occur. And this is where I would hand out my second handout, which is actually the first one on the sheet, and state that, and what they would do when they go through this handout would be to evaluate each statistic and determine whether it was racially framed or not. And then if it is racially framed, attempt to decide if there's a way that we could present this in a way that doesn't put down one group or another. Thank you for your time, and I hope you have a great day.